Now the AA model, so in order to provide this model, we have to understand what are the parties involved in this end-to-end communication. And it's going to be always the same three parties. So first of all, it's going to be the supplicant or the end client. Basically, it's going to be the device requesting access, which is going to be speaking with the authenticator. So if we speak about device administration, then the supplicant is going to be the user trying to remotely connect to a router via telnet to manage it. That's going to be the supplicant or the end client. If we speak about network access, then the supplicant or the end client is going to be the user who's trying to connect via VPN or via wireless or via wired to a network. Then we have the authenticator, which is going to be the device that the user tries to connect to, and that device is going to be enforcing the authentication to happen. It's also known as NAD, which stands for Network Access Device, or NAS, which stands for Network Authenticating Server. Now the authenticator, so it only enforces the authentication to happen, but it doesn't actually perform the authentication by itself. So it's going to relay the authentication information received from the user towards the authentication server. So in case of who's the authenticator? In case of device administration, the authenticator is going to be the device that I'm connecting to manage it. If we speak about network access, then the authenticator is going to be the access point I'm connected to, or the switch I'm connected to, or the VPN gateway I'm connecting to with a VPN tunnel. So that's going to be the authenticator, the device I'm connecting to gain network access or to manage a device, depending what is the use case. And lastly, we have the authentication server, which is the solution or device that performs the authentication for the user. It validates the user's credentials. It can be connected to identity sources like username and password, certificate services, or it can have a built-in database of users, passwords, and that authentication server can also be a certificate authority server as well. So it depends if the database to validate the credentials, if it's going to be username, password, or certificate, resides locally on the authentication server, or if the authentication server is gonna integrate with other remote solutions to validate the credentials, like with Active Directory or with a CA server for certificate validation. So as I was saying, it can behave like a proxy towards another authentication server. So for example, to quickly make sure everybody's on the same side in here, like if we speak, let's assume looking at the network, I would want test PCA to telnet to router 3, telnet, in order to manage it, in which case PCA is the supplicant or the end client, because is the device trying to gain network or device access. Router 3 is going to be the NAD or the NAS, because it's the device that asks for the user to be authenticated. It's going to ask the user, give me your credentials. It's the device asking for authentication and forcing authentication before allowing the user access in the network or for managing it. And then because router 3 is going to validate the credentials that the user types in the telnet session, is going to validate the credentials against ACS, then ACS is going to be my authentication server. Authentication server. Now, in order to perform that end-to-end model with those three parties involved, we have to understand what are the protocols that could possibly be involved in their most commonly used protocols for the user to be able to gain network access, or for the user to be able to gain device access for managing it. So in general, between the supplicant and the authenticator, we have for device administration, the protocol is going to be, if the user is connected to the console of the device, is going to be a non-IP, is just a serial traffic in there. If it's going to be remote administration, then the user is either going to telnet or SSH or HTTP or HTTPS to the remote device to manage it. If we speak about network access, when the user connects to a VPN, to a wired switch, to a switch, or to an access point to gain network access, then the protocols can be EP over LAN, HTTP, HTTPS, authentication proxy, SSL, IV1, IV2. Authentication proxy is not specifically a protocol, it's more of a method which makes use of other protocols. Like if it's gonna make use of authentication proxy, makes use of telnet, of FTP, of HTTP, of HTTPS. So that's gonna be between the subject and then the authenticator. But now between the authenticator and the authentication server, we have always either radius or TACACS plus. So in my use case in here, between the supplicant, which is testPCA, and the authentication server, the authenticator, which is router 3, I'm going to have in my case telnet, that's the protocol, for example, or SSH. And then as you're going to see between the authenticator and the authentication server, which is access ACS1, I'm going to have in there TACACS. So what's going to happen is that the user is going to present its credentials to router 3 to the authenticator via telnet. And then router 3 has to pick up those credentials and put those credentials inside a TACACS packet to be validated by the authentication server. So the authenticator always is responsible to translate the credentials that the user presents to the authenticator via whatever protocol, telnet, SSH, ICO, whatever. The authenticator has to be able to pick up those credentials and then relay those credentials further to the authentication server via either TACACS or radius.